Hello, good morning. So finally, hopefully, we are moving towards a more normal uh, environment as a family. So I'll have more predictable time to actually do work and streaming and all of this good stuff. Thank God for AI, or I think I would go insane because when I feel isolated at home, I have to use my brain to think about things, like other things than like playing Rocket League with our 4-year-old and just plain daily stuff. I have to do something. So what's fun about this stream is that I'm just jumping around to whatever's on my mind. And one thing that we've been discussing many times is like how to do UI, how to do state and how to do UI, right? And I made a statement about combining reconciliation and observation, but I wasn't sure how to do it. And then I kind of left it alone. But then I saw Remix 3 being released, and they actually, well, they're not doing the same thing, but it made it more clear to me because they use the same signature. So what I mean to start with here is like the 3 ways to do a component, or 4 ways to do a component. So we know React to be like this, right? Hello world. So this is React. And in React, the function is the component. So this function will be called again and again when it needs to reevaluate what to display in the DOM, right? And this is a really, really nice way to think about components. The problem is state management, because now you have to put state in here as well. So this is just really incredibly mind-bending, React hooks, because they're running inside the reconciliation loop. And then you have something like solid. Here the component runs, it looks kind of the same. Hello world. Let's actually put the full counter here. Count. Hello world count. On click set count. Sorry, count +1. Okay. So in solid, it kind of looks the same, but it isn't the same. Create signal. So solid depends on a compiler, and it depends on it to actually change the way the code runs. So if I do hello world count here, like this, on click, set count, count +1. So here the function runs once, right? Which is great for state management, but it looks like you're returning a static version of the UI. It looks like you're extracting the count value at the point of creating the app, which is not the case. And it doesn't reconcile, right? So it looks like you're returning something static, but it isn't static. So how does Solid do the dynamic UI? And the way it does it is that this count over here isn't actually this. It's actually translated to this. So you have basically reactive children. So anytime you have like a child like this, you can pass it a function. So it's basically this that is happening after the compiler is done. Only it's like shortened by this. So you just have the possibility to pass a function as a child of an element. And that will kind of update in place, which is really, really cool, right? So instead of like here, it needs to compare the previous H1 with the new H1. Here, it doesn't do any diffing. It just sees that, oh, this function ran. I need to update this text node, this specific text node, which is really, really cool. But that's kind of the buy-in, is that instead of thinking of the whole component as like a reconciliation mechanism, you have to think about like different points in your static UI that is reactive, and the code you write isn't true. Like this isn't reactive, this is static, but because of the compiler, it becomes reactive. So it, like, that's kind of the buy-in thing. And then you have special components for doing for loops and so on, which you don't have to do here. You just use plain JavaScript. So that's solid. And then you could do like a completely separate like templating language, right? And this is why people like templating languages, because you can design syntax that you have to learn it, but it expresses exactly like the dynamic nature. So you don't think about dynamic nature as JavaScript runtime, which you do here. So this, maybe this is kind of the thing. It's like with JSX, you're so close to the JavaScript runtime that you actually understand what's happening. But with a templating language, you have no idea what's happening under the hood, and you don't fucking care, right? So you can like create this syntax that gives the most like abstract conceptual sense, and then everything else is just handled under the hood. I personally don't like that. I like to just use the language. And it has to do with TypeScript specifically. I know that these templating languages like Angular and Vue has gotten better with TypeScript, but there's something about like them having to maintain like a typing layer on top of this custom syntax that will never be the same as just using the language. But yeah, and then you have Remix 3, which is also just an app. But they return a function that is the actual thing. I can't remember exactly their primitive for state, but let's just imagine it's this. Count. Oh, I don't think they even have that. I think it's just state, count 0. And then you can do, let's see. I think it's like, at least conceptually, it's like this. State count plus plus, and then you say this. Is it update state or something? Something like that. State.count. So my point is that you do have a reconciler, but the reconciler is running in the return function. So everything here, the function app runs once. But then you return a function that's reconciling. And here you have to like manually tell it when to do that reconciliation. And immediately you think like, oh, what the hell, do I have to manually do this? But the point is that they don't want to take on state management, which is actually quite brilliant. They just give a hook for state management tools. So any tool, like I could create my own create remix state like this. That's like a proxy that will under the hood call, I guess I will have to do something like this, or something like this set update state or something. So I could create my own kind of state management thing. And there's so many state management solutions, right? So you can like pick and choose that, which is kind of nice. But the point is that they actually do combination of reconciliation and not reconciliation. So, and this is what I wanted to do as well, but I wanted it to be reactive. So this thing I'm just calling Rask, it's kind of funny because it's based on Snabdom, which is a VDOM library. And snab means fast in Swedish, and Rask is fast in Norwegian. So yeah, I thought that was funny. But the point is, here you actually do, you have first class handling of state, create state, count 0, and then, well, maybe I can show it to you. So I'm gonna just, so we keep this update state. But the point of Remix is that, again, it's just JavaScript, right? It's as pure as you can get it, though it does have like, it makes the function, has like a this context and stuff like that, which you might not like. I don't like it. But it's just JavaScript, right? That's the point. And it runs exactly how you expect it to run. But Solid is really great. Like, it's definitively the fastest, most performant one, because it has these dissected updates. But you do have to accept that the code you write isn't technically the code that runs. You need these special primitives for dynamic UIs. You can't just use JavaScript. Cool. So, what about Rask? So here we have, so the cool thing is I used AI for this. I learned a shit ton. Just like conceptually, how should this actually work? How do we create a component abstraction over, because I was using something called Superfine first, but Superfine didn't have the mechanisms needed to actually create a component concept. But Snabdom has it, at least to the extent where I'm at now, feature-wise. So the way this works is that we have an app and we're returning like some static UI here. And if I want to introduce some state, I can do that with create state. Currently, this is a shallow, it's not even a proxy. It's just a getter setter, but it's going to be a proxy. So, but I can do state.count like this. And, oh no, didn't I? God damn it. Oh, because I've been playing around with it. I didn't test it after I made the last changes. Oh, that's embarrassing. Oh, what did I do? Oh, so I re-implemented everything manually. So I have like full control of the code now, which is good. But when did it start breaking? Think. Oh, I should have tested this first. Thinking. Why? Okay, let's just see if it reconciles first. What? Oh, I don't have the on click. Sorry. Oh, my bad. State count. There we go. Yeah, it's just some debugging information here. That was embarrassing. Okay, so this is how it works. Then if you think about components in these different solutions, so in React, for example, there isn't any, like, components are really just wrappers over the virtual DOM. Like, it's wrapper over this stuff, right? So there aren't any clear boundaries, really, which is, I guess you could say, good, but at the same time, there isn't a clear boundary, and you kind of think of components as a clear boundary. So what you experience in React is that even though, so you have this big component tree, it doesn't matter where you change state, it will reconcile all the way down, right? Which is kind of the problem with React. It kind of breaks the mental model of a component being an isolated concept, and it has performance issues. Like, it's the big thing with React. With Solid, since you don't have a virtual DOM that's going to be diffed, there is no reconciliation happening. It's just you're consuming these reactive values in the elements themselves and with these special components, and that keeps everything up to date. So how should I put this? So with that, you feel like you have boundaries around your components, right? One component can't just suddenly affect another component. Here, I'm not sure what they're doing. That will be interesting to see. If one component reconciles here, you have a nested component, will that also reconcile? Might be. I don't know. But in Rask, I'm gonna call it Rask. In Rask, you have true isolation. So an app component is, in the virtual DOM world, is a virtual node, right? So the first time you render, it goes through and it builds up all the components. It renders out the full virtual DOM. But after that, there's nothing one component can do to affect another. The only boundary is there's a reactive boundary between components. So if I were to add function counter here instead, let's put the counter in here. Let's just put this in here, and I'm going to put counter in there, and then we'll do this instead. So it still, like, works the same. But what if I start moving the state up here, for example? And we're going to pass count. Yeah, we're going to just pass the count. So I'm just going to talk through this stuff. Let's see. So we have the counter. Count is state.count. We're gonna have a button, increment, on click, state.count plus plus. Oh no. We have a bug. Dagnag it. Why do we have a bug here? Why don't we have a component instance here? Pre-patch. Oh, I think I know why. Sorry. Render pre-patch. Oh, sorry. Component pre-patch. We have to copy over the stuff first. Let's see. There we go. There we go. Sorry, tiny bug. So the point is, we are now passing down a prop, right? And props are reactive. So when this evaluates, it doesn't just go in and start reconciling the counter. What's actually happening here is that the reactive props of the counter component is updated with the new value of state count. And then since you're using that count, it's gonna reconcile it, right? So it does reconcile this, exactly what you're seeing here. And then there's a reactive reconciliation of this one because one of the props you're passing down is actually being used inside this one. Okay, so there's two reactive concepts here. You have reactive state and you have reactive props. And then we could look at something else, which is interesting here. What if you pass state.count as a child? Children, I'm not sure. Yeah, children, I guess we can do that. So what's interesting now, and this is also, oh, it might be, let's see if, is this, I'm still working on showing children correctly. Oh, is it an empty array? That's weird. Shouldn't be an empty array. Let me check. That's also a bug. Just gonna keep tabs on. Just 2 seconds. Been the most. Let's see. Okay, sorry. Yeah, so there's something weird going on with the children here. And the reason that is because I changed from calling JSX to use like JSX as a function and using actual JSX as a syntax. And I think there might be something going on related to that. Oh yeah, this is it. So if children is undefined, or sorry, yeah, if it's undefined, then it should be empty, or it's because it's 0. The number is 0. My bad. There we go. Okay. Let's see. Cool. So what's interesting about this is, what are children? Like, who owns the children? Who are, like, what are they? How are they evaluated? So if we think about this, it's like we're passing in state.count as a child update. Sorry, as children. And if I click state here, I'm going to increment that count. And then the question becomes, what should happen? Like, should children act as just another prop? Because what would happen is that whenever I change the state here, it's also going to reconcile the counter. right? And that makes sense in this case. But what if I did something like div state.count, something like this? Like the children will always change. So if something else changes here, this will always change. And this is true for React as well. I want to actually test this because I wasn't sure about this. Let's take a look. Let's take a look at this. I think this is something that people don't quite know about, or even think about. Let's see. We can just use the sandbox for this. Ooh, can I click you? There we go. So what actually happens if I do function nested return hello nested? Let's do an H4 for that. Nested. Okay, and then we're going to see a console.log rendering. Of course, this is rendering, right? And we're gonna do a state update here. Let's do count. Set count equals use state 0. Just do the same here, and on click set count plus 1. But what I really wanted to do with this like overview down here is I want to create kind of a presentation to make people aware of what choices they have and how they actually differ. Like I think comparing these three approaches makes a lot of sense. I think it would be very insightful. Anyways, so if I click this, of course it renders every time, right? But what oh fuck. But what happens if I make it a memo component? Nested equals memo. Memo. And then we render. Then it doesn't render again, right? As expected. But what if we do this? You see that? Now it renders again, right? And the reason is because that every time we run this code, it's going to create a new, like this is just an object for React. And that object is new every time. So it's going to trigger reconciliation. But if I do something like this, children, and the thing is that it's still gonna reconcile again because of reconciliation, we're still creating a new reference here every time, right? But if I do use memo like this, so we only create it once. Now it doesn't do it, right? So I think this is something that's valuable to have control of. So if we go back to the example, if I increment now, nothing's happening because you're statically sending this in. And the only thing that reconciles now is the app. You haven't like told the counter reactively to update. So if you actually want to pass children down, Well, this is what I'm thinking about. Like, what makes most sense? I could make the children reactive so that every time you pass children to a nested component, that nested component will always reconcile with the parent. That's predictable, right? But it's probably not really what you want. Because maybe you do have something static here that should only like render once. So what you can do in this case is I could make this a function instead. Like this, and then this is gonna be vnode. Oh, I'm not exporting that. Let's just do any. And we're gonna call it instead. Oh, is that inserting something? It looks like it. But you see now it's oh yeah, sorry. I have this div here. Let's just do this. I forgot about the div. So now it's reactive. And that is because it's reading the children as a function while it's doing this reconciliation. So this is as reactive as accessing any props. My point being that children is this special property where you're not quite sure what you want to do with it. So I think for solid, what does solid do with children? Oh, it's kind of annoying that it always goes to the old. Always goes to the old one. Do we have like children here? Oh, that's a children helper. Yeah, I wonder how children works. Passing props to children. Safe children. Simply using props will work without, however, we're accessing multiple times can introduce problems and unexpected behavior, such as repeated creation of child components or elements. Yeah, like this is the thing. It's like there's so many weird things you have to consider when you do like a full reactive solution like Solid. Like this stuff is like, why? As repeated creation of child components or elements. Interesting. Yeah, I don't understand how people get past this. Like if this was an issue when I built something that you have to do something like this, it's like, to me, it's such a glaring fault of the approach that like, no, this is an indication that we're doing the wrong thing. There has to be a different solution to this. Because having band-aids like this, it's like, I don't understand how people can accept this. I mean, and this is not to like badmouth Ryan in any sense. He's like an extremely intelligent guy. It's done a lot of good for the community. But I don't understand this. Like, what is the internal reflection when this was created? Like, what was the problem? What was the reasoning? Why was this okay? Why was the conclusion, oh, let's just create a function that fixes it? Yeah, anyways. So children are tricky. So currently, children are treated as static things. But I'm not sure if that's the right way to do it. I thought actually React did some trickery where it would update the children in place. But that's not true. Or does it? I think they have something. Because if these children, like if I do, yeah, this is what I want to test. Div count. If I do this. And I have a memo thing here. No, it is still rendering nested as well. Okay, cool. What was I gonna say? Yeah, so I'm still reflecting on children, because if you make children static, you are like opting into making them reactive by doing this. Or they can just be reactive like any other prop. But then it's not obvious to you that it's happening. Maybe they should be. And then what you could rather do here, like what you could do is no, that wouldn't work. Oh, sorry. No, it could work. So what you could rather do, if you actually had something static here. Hello, counter. So, sorry. Children. So if you do wanted something static, so you flip it around. Hello, counter. You could do this as well, right? I think. Oh, it's not a function. Sorry. Yeah, it's just a weird way I display it. So you could do this, and if I let's see. So if we do this, rendering counter. Oh, am I not displaying the count? Increment. Oh, there we go. So you see this, it doesn't do anything to the counter. Yeah, maybe that is better. So children are, yeah, I don't know. Like how do you typically compose children? Like I have a feeling that you're composing components, right? It's very interesting though, because it's much more performant to have yeah. No, yeah. This is an interesting concept. Oh, did I turn off the... Oh, there you are. Yeah. Anyways, yeah. It's probably better. It's more predictable. It's definitely more predictable. Yeah, I think we should change this. So this is more just like an epiphany. Like I've never thought about this in React, that children are like actual props. I thought they would reconcile in the context of the actual parent, like the app. The app would be the thing that kept the children in place, but it's not. You're reproducing the children, you're passing it as a prop to the nested component. The nested component is the thing that evaluates it. So children is like the worst prop possible to pass the component because it's new every single time, unless you do something like this, which is very interesting. I wonder if there is a way to manage it though. No, not really. Yeah, no, I have to think about that one. Anyways, so this is like the fundamentals of it. And then it has like all the bells and whistles of context. I haven't created ref yet, I think. Did I create ref? No, I haven't created ref yet. But it has context. It has unmount, on cleanup, all that stuff. That's really nice. And then you have like this very predictable setup of a component, return the UI. You have like full power of JavaScript, if statements, for loops, doesn't matter. That's just gonna work. So to me, that this is at least an example of merging observability with reconciliation in a way that I think works better than React, that's trying to merge setup and UI into reconciliation, or Solid that tries to merge setup and, well, state and UI into the reconciler, or state and UI into, yeah, I can't even compare them. They're so different. Maybe I should rather say React, which runs the function again and again, or Solid that only runs the function once, right? Here we have component is a concept where the function runs once, but it returns a function that runs multiple times. And that's the beauty of JavaScript, closures. Yeah. So I'm working on suspense. I'm not sure if I'm gonna make it work. Suspense is really, really tricky to do. The reason it's tricky to do is because it's not like the actual signaling of promises and stuff like that. It's the fact that you need to be able to run UI in the background. That's not actually mounted in the DOM, but it's still evaluating in the background. And yeah, let's do that test. I want to see if this is actually possible. Oh, I'm noticing I'm losing my motivation. I don't have much energy today. Okay, but we're gonna run this little test. Import h from. Let's just write the test in the thing. Export function test. So we're basically just gonna go to snubdom. So we're going to see if we're able to patch in the background. Let's just create a test file. New file test.ts. Let's just do this, and then we're going to run export function test. container. Let's just do any. Okay, cool. So that's our test. Let's export test from test. Oops. So basically what I'm wondering is here we have the initial node that we're patching on to the DOM. And then we're creating a new node and we're patching the old node. So what I'm wondering is, can I just patch a node? So we're not going to do this. We're going to first patch the old node with the new node. And then we're going to apply it to new v node. If this works, then suspense can work, because then we can keep patching the old UI, not the old, but the children UI. We can just keep patching that in the background until it's ready. And then we just return it from the actual suspense component. Yeah. Okay, let's see. We're gonna test this first. So I'm passing in the container. Let's. Where's the main file? Oops. Test. Does this work? Reading style. I don't think it works. It's trying to find. Yeah, it's trying to find. Yeah, this is not going to work. The reason is that it's trying to find the style of the element, but there isn't any element. So it's trying to apply the style update to the actual element, but as I said, there is no element because it's not been inserted yet. So what you could maybe do, well, let's just try this. So what if we do this vnode, but we're gonna let's see, let's build that, and we're not gonna insert it. We're just gonna const container document create element, like div or whatever, container, and then we're gonna apply it manually. So we're gonna say append child container. Would that work? No, that didn't work either. Or wait, did it do something wrong? That's interesting. Okay, but let's see now. Let's see if it actually works if I pass this thing in. Oops. Yeah. Okay, so yeah, I'm worried about suspense. I'm not sure how we're gonna make it work. Because the point is that the components, they are created through rendering, right? So you have to so we've rendered the actual children of suspense initially, but then the children says, no, you should rather render fallback. And that means that it unmounts all the components, right? But they shouldn't be unmounted and disposed of. They should still be there. Yeah. I don't know. I have to think about this. So there is a trick to it, which is to, so this is also interesting. So currently, I don't think I need this anymore, but currently, oops. But currently each component actually has a component. It's supposed to have a name here. I don't have the name right now, but it's actually a component in the DOM. And this was really because of Superfine. I don't think I need it with SnapDOM, but I think it makes a lot of sense to have it. And it doesn't affect styling. It does affect child selectors in CSS, but it doesn't affect styling. And it doesn't matter because, like, if you're using something like Tailwind, like any child selectors would be within a component, right? Or maybe they wouldn't. Maybe it would be a problem. Yeah, but I'm going to try to remove that. But for suspense, you could do something similar. So suspense could actually have two components or two elements that renders, and then you just choose which one to display. So you just hide the one that's the children until they're done, and then you hide the fallback. That's a very simple way of doing it. But yeah, maybe there is a way. Maybe we could, like, under the hood, we could actually render it in the DOM with display none. But it would be kind of a portal thing. But then we would have to change the element that it patches onto, which is a problem. Yeah, I don't know. I need to think about this, and I'm just gonna stop streaming because I'm I'm actually not super motivated to stream. And I'm gonna give like a proper introduction to this when my thoughts are more collected. Yeah. Okay. Cool. Bye.